University Wings and Yokohama Care Clinic. I am the ophthalmologist in Japan, and they're really sorry for me to speak in English. So I need there's a good translation here, so I'll speak it slowly. Okay, so today I will talk about the AI, okay, artificial intelligence. This is the precise of our study, what we have achieved and what we have done. We use the anterior segment OCT to measure the patient's anterior chamber depth. We use this smart eye camera, the portable slit lamp microscope, to record the patient's eye. Same patient, same time, same circumstances. And then we teach the video that value of the anterior chamber, and then achieve to make the AI to estimate the anterior chamber depth from the anterior side of cornea through the top part of clisthenic lens. Okay, so for the background, as we all know that the AI, the value of AI is increasing in the ophthalmology as well, starting from the retinal imaging, OCTs, fundus photos, and etc. There is one article which estimates papilla edema from the fundus photo, and that's published on the New England Journal of Medicine, the most valuable journals. So AI in the ophthalmology, we know have a high value, not just in the ophthalmology, but also as the whole practice. Now, let's move on to the anterior segment of the eye. We know that there is a limited AI use in the anterior segment, and today our topic is to measure the anterior chamber depth. Conventional method to measure the anterior chamber depth. We use optical biometers. We use the anterior segment OCTs to visualize and calculate the anterior chamber depth from these bulky and huge machines. Now, because those machines are huge, bulky, unmovable, it is hard for us to use it. Not though the rural areas, it's very hard for us to bring it to the outreaches, cataract surgery programs, anywhere in the rural places. So this is idea. If we can use this tool, get the anterior segment image of the patient's eye, and the algorithm to estimate anterior chamber depth, we can it have a huge value as well. Now, we use the portable slit lamp recording device. We call the smart eye camera. The slit lamp the same function as the slit lamp microscope. We already have evidence which this tool has the same efficiency, same capability to measure the anterior chamber depth versus conventional handheld slit lamp microscopes. We use anterior segment OCTs to get the measure the ACDs. This is a little bit of complicated. I'm sorry, this is figures taken from my paper, but pretty much simple protocol. So we gathered as many data as possible as a retrospective study from the one single clinic. We gathered 1,601 eyes from 803 individuals. We gathered a total of 206,000 images of the anterior segment images. We have an exclusion criteria. The data is only faking. So we exclude the IOL, we exclude the pseudo-faking eye, the IOL, aphakic eyes, and other complications which could not observe the visualized anterior chamber. Now, in total, 1,586 eyes from 797 individuals. Total, 204,000 frames we gathered. Now, the reason why the frame and the eyes are different, because we take video. So we take anterior segment video from the smart eye camera and slice all of the video into the images. So we have over 204,000 frames. Now, of course, all the frames would not visualize anterior chamber. If you want to see, if we see the central part of the anterior chamber, we can, of course, we can see the anterior chamber depth. But if the frames are not focused into the, for example, not focused on the cornea, focused on the eyelid, we could not use it. So we made two AI models. One is to extract the diagnosable frame, which can easily to visualize the central part of anterior chamber, and extracted all the frames, all other frames, which is the not focusing on the anterior chamber, eyes closed, any other occasions. At this model, we gathered 37,000 images are only included, and other 167,000 frames, most of the frames are excluded. Then, for those frames which is capable, eligible for the study, 37,000 frames, we developed the training, validation, and testing dataset, and acquired as an AI model. You can see the the alliance of all the eyes, and that we can see the normal distribution. This is the central anterior chamber depth, so that the range between about 2 millimeters to 4 millimeters. It's in the range of all the subjects. Now, this is a little bit complicated, but the most important slide. So for the left one, we shows that the diagnosable frame, the performance of the diagnosable frame extraction, which all those frames are eligible to measure the anterior chamber depth. This is accuracy was pretty much high, over 90.4% is accurate. Now, we label all the frames, whether that is left eye or right eye. And that accuracy was about 94% as well. Which means this first model, when we enter the anterior segment video to the model, they can extract diagnosable frame, pretty much accurate, and can divide whether it's a right eye or a left eye in pretty high accuracy. Now, this is the main result of the estimation of anterior chamber depth. So we used all the frames to do the machine learning. However, in the real world, we take the video of one patient. So in the real setting, we evaluate the performance with the one patient eye. So this means that the performance of the frames and performance of the eyes. MAE is stand for mean absolute error, and MSE is stand for mean squared error. Now, as you can see on the frames, the MAE and MSE was pretty low. So, which means that plus minus 0.118 millimeter. So if the AI suggests the patient's eye that is, for example, 3 millimeter, the real setting is that those range is only 0.118, which is pretty much accurate. Now, only the frame, but total with the eye, that the performance will increase up to 0.093 millimeter. Only 90 plus minus 93 nanometers. So it's pretty much accurate. Of course, if we use, for example, anterior segment OCTs, optical biometers, those are more accurate because that is statics and that's fixed, and that have a pretty much more high model. Our AI model is designed to use in the rural places, whereas there is no any microscope, nothing is there. We designed this device and this algorithm utilizing those places. Now, we looked at correlation of all the frames, eyes, and according to the cases. I'm sorry to say that this is pretty much kind of hard to see, but all the correlation have pretty much high, over 0.90 with the correlation coefficient. When we divide all the frames of the cutoff value of ACD from 2.5 or 3.0, which is the one value to see the risk of the acute angle closure. We can see that if the cut value is 2.5, this model can achieve at sensitivity of 100%, specificity of 45% when the cutoff is 2.5, and when it comes to 3.0, sensitivity 94%, specificity 90%. About this result, this is pretty much hard for us to see because things are all divided, and the risk cutoff ratio of the anterior chamber depth, I believe it according to the races, countries, and circumstances. This is the most simple slide to see. This heat map shows where the AI is observing. So most of the slides from this model, this AI sees where the heat map shows where we see the ophthalmologist see in the real world setting. Now, for the discussions, we could not find many articles which shows the algorithm of the anterior chamber depth estimation. I found only two. The first one's MAE was 0.2 and correlation coefficient 0.6. The other one, which is like this one, is 0.16 and correlation 0.4. These two models did not use anterior segment photon. I'm sorry, the segment photon. They are using diffuse photon. So I believe that is a difference because our model are using the slit lamp images. Plus, we have about 10 times or more data for the AI. So for the limitation of the study is that the eyes are only phakic and the eyes are all not dilated. The second is that the video is only taken by SEC, so we need to do the further validation using the normal slit lamp photo. And the third one is the video was only taken by the professional, which is ophthalmologist. So we want to do the further study, non-ophthalmologists, but the optometrists, nurses, we want them to take the video and validate the data. Okay, so that will be pretty much for my presentation. Thank you so much. Goodbye.